numerator and denominator by x plus 4. I don't know. You have to get rid of the denominator.
There you go. You got it. Here's the problem with this problem. Is the denominator has two terms in it. You got to turn the denominator into one term. One, what is called a rational quotient. So let's look at this separately until we figure it out. This is where we're going to begin. How do I add those two things together?
The denominator needs to be the same.
What's the least common denominator going to be?
One.
The denominator is always going to be the product of the two variables.
So x, y.
Okay, so that's my least common denominator. What needs to go there so that I don't change that fraction?
Oh, so 1. 1x1. Y?
Notice that at every level when you're doing algebra, make sure that when you go from that step to this step, that you do not change that fraction. Only by putting a y there do I not change that fraction. Notice that now the y's cancel and I end up with 1 over x, the same thing I started with. Okay, so what has to go here?
An x.
Okay, so now this thing has become y plus x over xy. And that is a rational quotient. In other words, now I can write this thing the following way. Instead of writing 1 over x plus 1 over y, I'm going to write it like this. And now I can apply the rules of dividing fractions. How do I divide something by a fraction?
Multiply.
Flip and multiply. Always have to do two things. In other words, I can't just multiply that by that. That can't be the same because right now it's asking me to divide that by that. But if I flip the bottom and multiply, then I can do that. And the only reason I can do that now is because my denominator is a single rational quotient. It wasn't a rational quotient when it was in that form there. It was the sum of two different fractions. So you can't flip and multiply when you're doing division until you get it as a single rational quotient. And now the answer is what? What's xy times xy over y plus x?
I don't know.
What's x times x?
X squared.
It's y times y.
Y squared.
And the denominator, since we're multiplying, you multiply numerators and you multiply denominators. In other words, multiplication is far easier than addition. So this is our answer. This is our final answer. All right. Now, this is called, in my book, Advanced Algebra 1, although I'm not sure that it coincides with the Algebra 1 that you've already taken, but it doesn't really matter. These are good problems anyway. that equal to?
A squared plus B squared plus C squared plus 2A plus 2B plus 2C.
No. In other words, I want you to think of the numerator in a greatest common factor sense. What's the greatest common factor you can pull out of the numerator?
An A?
Well, that's one thing. I can pull an A out from each of these three terms in the numerator. What else can you pull out?
B, C.
Uh-huh.
B and C.
What's left over?
A plus B plus C.
Hold on. A plus, yeah, plus B plus C. Yeah, you were well ahead of me again. Still dividing that by A, B, C. And see now why it was really helpful to factor the numerator?
Yep.
Now those cancel.
Wow.
That's my answer. So always be thinking factoring, always. Whether it's greatest common factor or difference of perfect squares or just a general quadratic factoring, always be thinking factoring. Not always. I mean, like this problem is not. But when will this quantity be equal to 0? When x is what? The problem, the problem actually says the expression will equal 0 when x equals which of the following. So let's complete their statement. Now let's solve that.
So, add the 6.
Okay, so read me the next line.
3 over x minus 1 equals 6.
Okay, and the next line.
Multiply the x minus 1 by both sides.
Okay.
Yeah, 3 equals 6x minus 1.
6x minus 6, if I'm going to go ahead and multiply it out. Okay, next line.
Add the 6. So you get 9 equals 6x divided by 6.
Okay. If A over B equals 1, for some reason I like algebra a whole lot more than geometry. I'm so glad I had so many geometry students last year, and they're all turning into algebra students this year. That makes me very happy. What's that equal to?
The top part, what would B over A?
If this is true, then what is B over A equal to?
So it's the inverse, so it's
It's not quite the inverse, the reciprocal is what
reciprocal. Okay, so it'd be 1 minus x over 1.
Reciprocal of that. What do I have to do first before I can figure out what the reciprocal is?
Switch them.
Not switch them. Go ahead and do that at subtraction. What is 1 minus 1 over x? What's the lowest common denominator? goes here?
X. 1.
So that's really what A over B is equal to, right?
Mm-hmm.
So what's B over A equal to?
X over X minus 1.
Yeah, now you can flip it. In other words, it's okay to flip it. Again, once I get it into a single, that's called a rational quotient, as opposed to this. That's not a rational quotient. That is the subtraction of two numbers. Okay? So once I get it into a rational quotient, then I can do things that involve flipping, whether I'm, trying to divide or take the reciprocal, it doesn't matter. But you can't do that step until you get it into a single rational quotient. I don't know why this one is on the page. Some of these aren't that hard. Oh, kind of maybe I understand why. Solve this for y.
So multiply the 3y plus 2.
What's a quick way of multiplying those two together? Notice that these two things are the difference of perfect squares factored, right?
Mm-hmm.
So to multiply them back together again, you don't actually have to go through FOIL or ET. It's just this term squared minus this term squared is the answer. So what is it?
3y squared.
So what is
3y squared minus 16.
Well, okay, it's 3y parentheses squared, so it's 9y squared minus 4. That's what this multiplied by that's going to be. In other words, if I gave it to you in this format, you would say, oh, that's the difference of perfect squares. That's 3y minus 2 times 3y plus 2. So it's important in almost every aspect of math to be able to go both ways. You not only want to be able to factor the difference of perfect squares, but you also want to be able to multiply them back together again quickly. So, what did I have? I had 9y squared minus 4 equals negative 1. Now what?
Add the 4.
Okay. Now what?
Divide by 9 to get 1/3.
Now what?
Square root. Get 1/3.
Now simplify, because there's an inherent problem in this answer that's not totally obvious. Notice what that is. That is the square root of 1 over the square root of 3, or 1 over square root of 3. What's wrong with that answer?
Can't have a radical.
So what do we have to do to it? It's called rationalizing the denominator.
Okay.
How do I do it? How do I get rid of that radical 3 in the denominator?
I don't know.
By multiplying. In other words, I can multiply any fraction by the number 1 without changing its value. Okay? This is not equations. I can't do anything that I want to the numerator as long as I do it to the denominator. I cannot do that, but I can multiply this fraction by the number 1. Well, what's my number 1 going to be? My number 1 is going to be that. And that gives me square root of 3 in the numerator, turns the denominator into a rational number. Now I have the answer in a presentable format.
All right.
Okay, so whenever you see something like that, where you have the square root of a fraction like that, know that that's not going to be a final answer because it always has to be rationalized. That's going to turn into square root of 5 over 5. Now, of course, if it's the square root of 1/4, then that's 1 over 2. So that doesn't need to be rationalized. But whenever you see fractions where you're taking the square root of the entire fraction, understand that that's not rationalized. Even if I was taking something like the square root of 2/3, it gives me the same problem. I end up with the square root of 2 over the square root of 3, so I still have to rationalize it. But it turns out going to square root of 6 over 3 is my final answer. But whenever the denominator is an irrational number, you're going to have to rationalize it. Whether the whole thing's in a fraction or whether part of it is. In other words, it wouldn't matter if it looked like that. I got to rationalize that, but I also have to rationalize that. All right. Advanced algebra looks like, it's not that advanced. It's stuff you got in Algebra 1. Things like inequalities and stuff like that. Most all this stuff is what you'll review in the first couple of weeks when you get back to school. Just giving you a little bit of a head start. It's always nice to start out strong. Although that probably didn't happen to you in geometry. Because in class, you spent the first month or two doing proofs. And you and I had not done proofs last summer. I specifically stuck with the easy geometry to get you started. So I don't think that'll happen in algebra. I think what you'll start off with in algebra is the stuff we're covering now. Maybe linear programming. For some reason, they insist starting off every math course with some of the toughest material. Doesn't matter if it's geometry, algebra, trig, calculus, precalculus. Every one of them manages to find the hardest material of the whole year and start students off that way. I don't get it, but anyway, what's the next step here? What's the next line?
3x is greater than 60. Divide by 3. So you get x is greater than 20.
Change the problem to that. Now solve it.
All right, so it remains the same. So you have negative 3x is greater than 60. However, but when you divide the 3, it becomes x is less than 20.
Don't forget you have to divide by minus.
Oh, negative 20. Negative 20, yeah.
It's very easy to make that mistake because you've already made your change right there.
Yeah.
So a lot of people are in the habit of, well, you only have to do one thing, but you actually have to do two things. You still have to divide by the negative 3, but you have to switch the sign also. And that's pretty much the only difference between equations and inequalities, except something maybe like this. What'd you do here?
I have no clue.
Well, it's tempting to cross multiply, right?
Mm-hmm.
So you end up with this, but that's not correct. And the reason it's not correct is because when I cross multiply, I'm multiplying first of all both sides by x, second of all both sides by y, and if those variables are negative, it's going to cause me to have to switch the direction on this thing. And I don't know if they're negative or not. So when you have inequalities and variables, be very careful about multiplying or dividing by a variable. You can't do it. In other words, I could not do that. The way I need to solve this is I need to move the 1 over y to the left side. And now I would need to make it into a rational quotient, much like the other problem, and go from there. And now how you go from there is a whole nother story, but my point of this problem was you cannot multiply both sides by variables when you have inequalities, if you do not know if the variable is positive or negative.
All right.
Okay. All right. Cole, I will talk to you next Monday.
Talk to you next Monday.